Chapter 1 Metallurgy. Metallurgy relates to the science and technology of metals. In nature, only a few metals occur in their native state. All other metals occur in a combined state as their oxides, sulfides, silicates, etc. The extraction of pure metals from their natural sources is linked to the history of human civilization. Ancient people used the available materials in their environment, which includes fire and metals, and they were limited to the metals available on the Earth's surface. In the modern world, we use a wide range of metals in our daily life, which is the result of the development of metallurgical knowledge over thousands of years. Our need for the materials with specific properties have led to production of many metal alloys. It is essential to design an eco-friendly metallurgical process that would minimize waste, maximize energy efficiency. Such advances in metallurgy is vital for the economic and technical progress in the current era. In this unit, we will study the various steps involved in the extraction of metals and the chemical principles behind these processes. Occurrence of metals. In general, pure metals are shiny and malleable. However, most of them are found in nature as compounds with different properties. Metals having least chemical reactivity such as copper, silver, gold, and platinum occur in significant amounts as native elements. Reactive metals such as alkali metals usually occurs in their combined state and are extracted using suitable metallurgical process. Mineral and ore. A naturally occurring substance obtained by mining which contains the metal in free state or in the form of compounds like oxides, sulfides, etc. is called a mineral. In most of the minerals, the metal of interest is present only in small amounts, and some of them contains a reasonable percentage of metal. For example, iron is present in around 800 minerals. However, some of them such as hematite, magnetite, etc. containing high percentage of iron are commonly used for the extraction of iron. Such minerals that contains a high percentage of metal from which it can be extracted conveniently and economically are called ores. Hence, all ores are minerals, but all minerals are not ores. Let us consider another example, bauxite and china clay. Both are minerals of aluminium. However, aluminium can be commercially extracted from bauxite, while extraction from china clay is not a profitable one. Hence, the mineral bauxite is an ore of aluminium, while china clay is not. The extraction of a metal of interest from its ore consists of the following metallurgical process: concentration of the ore, extraction of the crude metal, refining of crude metal, Concentration of ores. Generally, the ores are associated with non-metallic impurities, rocky materials, and siliceous matter, which are collectively known as gangue. The preliminary step in metallurgical process is the removal of these impurities. This removal process is known as concentration of ore. It increases the concentration of the metal of interest or its compound in the ore. Several methods are available for this process, and the choice of method will depend on the nature of the ore, type of impurity, and environmental factors. Some of the common methods of ore concentration are discussed below. Gravity separation or hydraulic wash. In this method, the ore having high specific gravity is separated from the gangue that has low specific gravity by simply washing with running water. Ore is crushed to a finely powdered form and treated with rapidly flowing current of water. During this process, the lighter gangue particles are washed away by the running water. This method is generally applied to concentrate the native ore such as gold and oxide ores such as hematite, tin stone, etc. Froth flotation. This method is commonly used to concentrate sulfide ores such as galena, zinc blende, etc. In this method, the metallic ore particles which are preferentially wetted by oil can be separated from gangue. In this method, the crushed ore is suspended in water and mixed with frothing agents such as pine oil, eucalyptus oil, etc. A small quantity of sodium ethyl xanthate, which acts as a collector, is also added. A froth is generated by blowing air through this mixture. The collector molecules attach to the ore particle and make them water repellent. As a result, ore particles wetted by the oil rise to the surface along with the froth. The froth is skimmed off and dried to recover the concentrated ore. The gangue particles that are preferentially wetted by water settle at the bottom. When a sulfide ore of a metal of interest contains other metal sulfides as impurities, depressing agents such as sodium cyanide, sodium carbonate, etc. are used to selectively prevent other metal sulfides from coming to the froth. For example, when impurities such as ZnS is present in galena, PbS, sodium cyanate, NaCN is added to depress the flotation property of ZnS by forming a layer of zinc complex on the surface of zinc sulfide.